So I had question 13 for problem solving set 6. Question 13 says complete the value or compute the value of a for which the intersection of the graphs of y is greater than or equal to x over 5 absolute value and y is less than or equal to a times absolute value of x plus 15 is a region having area of 45. So the first thing we need to do is we need to make sure we remember that the area is 45. And also we're going to write down both equations. So we're going to do y1 is greater than or equal to x over 5 absolute value, and y2 is going to be less than or equal to a times the absolute value of x plus 15. So first thing I'm going to do is I'm going to draw a graph here to try and get a rough idea of what the graphs look like. So we'll go back here, here, and I'm going to go ahead and make a table for y1 since that's a little bit easier to plug into. So we'll go up here, so we're gonna have x, y1, so I'm gonna plug in negative 10, so negative 10 over 5 is negative 2, absolute value makes it 2, negative 5 over 5 is 1, negative 1 that is, absolute value makes it positive 1, 0 over 5 is 0, plug in 5 over 5 is 1, absolute value keeps it as 1, and plug in 10 over 5 is 2. So we have these points right here, so we're going to graph these. 5, 10, negative 5, negative 10. Do that. We have 1. We have 2. So now we have our y1 graph right here. So we'll go and fill this in. And then our second graph has a y-intercept of 15 from right here. So we're going to go and put that about right there. And we're supposed to solve the area of like right here between the two graphs. And a normal from this equation, this is going to have a positive slope for the absolute value, so it's going to look something like this. And that's going to have an infinite area, so that definitely can't be right since the area is known to be 45. So that means A has to be negative. That way, when it comes down, it intersects with the y1 graph. It creates 2 points that restrict the area, so that way this area has a chance to be 45, because if it went like this, there's so many values that it can't equal 45, so it'll be infinity. So we got to find this point and this point. So then what we know about this is this area right here, I'm going to write this in a red pen, is 45, and we got to solve for all of this. And so what we're gonna do is we're gonna set these equal. So these triangles are identical on each side, and an area of a triangle, as we've learned before, is 1/2 base times height. So for the base, we're gonna use the y value right here of 15, since we're already given that. So we're gonna have 1/2 times 15 times height. Now height is gonna be from the wherever they intersect all the way to the y-axis. So this point right here can also be written as x comma x over 5 from the two graphs right there. So since they intersect there, so then that is going to be our height, which we can just put as x. So 15 times x times 1 over 2 is the area of a triangle, which also simplifies down to 15x over 2. Okay, so then since they intersect and they equal each other at this point, we're going to want to plug in and set them equal to eventually. But what we're first going to do is, since the whole area right here is 45, half of it is going to be 45 over 2, and that's the area of the triangle. So what we can do is we can take 15x over 2, also known as the area of the triangle, and set it equal to the whole area divided by 2. So we're going to go ahead and solve this. So 2 will cancel when we multiply by 2. Giving us 15x equals 45 divided by 15, x is going to equal 3. And that's great and everything, so like this will help us find this point here. But what we're trying to find is we're trying to find the a value, since that is going to tell us what like the negative slope is here. So to find a, we're going to set y1 equal to y2, like I said earlier. So x over 5 is going to equal ax plus 15. Plug in 3 for x, so 3/5 equals 3a plus 15 multiplied by 5 to cancel out the denominator. So we get 3 equals 15a plus 75. Subtract 75 over, so you're gonna get negative 72 equals 15a divided by 15 to get us an a value of negative 72 over 15, which turns out to be our answer. And to back up the thinking from earlier with the whole negative value to create the two boundary or restriction points, this a value out front is going to take a normal absolute value graph, which would look something like this, with a positive a value, versus since this is negative, it's going to look something like this with a negative a value. So that way we can plug our original thinking in, and this answer is going to back up our original way of thinking, which is how I know this answer is correct.